By the way, so far so good, indeed.
Okay, thank you. Thanks a lot. Okay, the last point. So I focused, so what we have focused 30 seconds, a review of the previous part. So with Petri-nets, with identifiers, we focused interaction of objects in terms of control flow. So multiple elements interacting in the system. We would like to understand if the order of the activities in which they are executed on the real system comply with the specification, which is the model. Then with colored Petri-nets, we extend this idea. It's not only their interaction in terms of control flow, but also the data that they have associated. So did all the attributes of an order after the execution of an activity change it as the model requires? This is the second part. Now, what happens when we do not want to focus on the attributes of the object, but we want to focus on its autonomous behavior and its interaction also with the system? In this particular case, we will resort to the idea of nested Petri-nets. What are nested Petri-nets? It's a kind of Petri-net that consists of a system net, like any order, like a ordinary Petri-net. But now the tokens, for example, here in SN, we will call the net tokens. And now they will not carry some data. They will carry an individual model, which is a Petri-net, an ordinary Petri-net. In this way, we can model how multiple agents, the agent is represented by the net token, and it has an internal behavior. What do I mean internal behavior? Ordinary Petri-net that where we describe what should be the expected behavior for this particular agent. In terms, again, behavior in terms of control flow, activities that the system can execute, in this case, the platform and the agents, and their causal dependency. In this is a very small example of the FIX protocol, Financial Information Exchange Protocol. So this is a standard used in trading systems. And I focus on the session layer. The session layer is the one responsible for the communication management of the agents and the platform. For example, the agent Ben sends a request, it will be waited, and now he should wait that the system grants him access by the execution of the logon activity, moving him, Ben, in the system net from the source place to the output place. And of course, naturally, there are different kinds of steps in this system. So we can have autonomous steps from element autonomous steps. So this means that firings of transitions only in the model that represents Ben. But we can have also system autonomous transitions. So this means to move one of the tokens representing one agent in the system net from one input place to one output place. Or we can have a combination. This is the synchronous steps, where transitions in the system and in the agents are synchronized in such a way that when they fire, it occurs a change in the markings in both the involved tokens and the system. For example, here in this model, this alpha 1 represents that transition logon, it's synchronized with the transition T1 logon in the system net. So when both are enabled and they fire, for example, Ben, let's suppose that there should be a token here waiting, in the place waiting. If this fires, and also Ben is in the input place of the transition logon, then there would be a synchronous step. Why this synchronous step could be useful in our case? Because it would allow us to represent, and actually it allows to represent the interaction between a Ben, between an agent and the platform. So this allows to study more not the perspective of the orders that are inserted in the system, in the platform, but it allows to understand the communication management.
Excuse me, please.
Yes, of course.
You perfectly explained how agent can interact with platform, but how do different agents can communicate directly with each other?
No, so specifically...
Okay, it's enough, it's enough. It is just my assumption, okay.
Okay. Actually, the model Petri allow also this. So if when tokens are in the same place, there can be an horizontal synchronization. So we have horizontal, which is agent, or we have vertical, which is system and the agent. In our particular domain, this is not required, so we only consider vertical from agent to the system. So then also we define it, okay, so if we have this kind of system, we are studying this particular slice perspective of the system, management of communication, agents and the system, how we can understand, having this model, if the real process that we are modeling like this complies the model itself. Well, for this, we need to define how we are going to model the real behavior of the system. So when the process executes each time, every trace, what the events should contain. Now they should have more information or a different perspective of the information. So for example, for this trace, even E1 should be, every event should have the name of the activity that was executed and identifiers of the agents or the system itself. For example, E1 means, this pair means that I am executing the activity create order on the net token Ben. So then I go to this token, to this net token Ben. Is it possible to execute for this particular Petri net of Ben the transition create order? Can I fire? I cannot. You see the input place application thread is empty. Here there is a deviation. And other format of events. The second event, receive order, and I see here send order Ben. In the way that we defined this means that the system net should execute receive order, and this is synchronized with the execution in Ben of the application of the activity send order. Actually, you see this alpha 3, so this means that this is correct because actually both transitions are synchronized. So, but then also we need to check the input place, the preconditions of each transition. Are they filled? We have the correct token on each. So for executing receive order, there is Ben in the input place online users. Moreover, Ben is enabled for executing send order. So we can check this if this is correct. And the same idea, for example, if one token, let us suppose that we want to execute the activity logout, and the input place where there should be the online user, there is no token there. So we can force again the jump of the token, so wherever the token is, to move it to the input place and to register this deviation. So this token was not available in the logout. So how is it possible that it's executed the logout in the real system if the token was not ready in that state? And we have also the deviations not only at the level of the system, but we got to a hierarchical model where we can discover deviations on either at the level of the platform or in the workflow associated by a distinguishable agent. I will move to the part of the experimental evaluations to mention some of the experiments we did on the thesis. First of all, about the software. So we worked with a set of command line tools that were developed in Python that implement the presented model and the validation methods. So we have, on the one side, conform and checking methods. They were developed like Python scripts. Also, the PetriNet models, they are Python scripts. So we have a class. I will show us a snippet code in Python to understand how this could look like. And then we can pick a particular log. Also, we have a repository of event logs. we pick a particular log, a particular method out of the three that we described on the thesis, and a particular model. And we generate the deviations. So this is the one of the main important things. So the difference between the model and the log. So for example, this model on the left can be built as a Python script, and we use it snakes, which is a Python-powered library that allows to construct and to simulate different kinds of high-level Petri nets. So you can see here that it says Petri net equal Petri net. So this is an object. So we follow the idea of object-oriented programming. So this object Petri net, we can have methods. So you see that there are methods at place, at transition, at input. So we construct the Petri net in the software like an object. And the idea is we have the log. The log can be a CSV file, a comma separate value file. And the idea will be now to run this object, this model, according to the information in the event logs. I will go to one interesting example that we did on the thesis. So we got the data of a real trading platform. So what we did, we had a set of fixed messages that they were captured by snipping a channel during a trading day. So the agents and the platform, they communicated during a trading day from 7 a.m. to 4 p.m., for example. So there was some behavior, and then we need to extract. So this also we worked on the thesis, how to extract from the fixed messages the information about the behavior of the agents and the platform. And we got to an event log. In this particular example, the trace, so each process instance refers to an order book. So we have in one trace all the activities that were observed for the traders interacting with the order book Rosneft, the people that was buying and selling Rosneft. In another book, in another trace sequence of events, we have all the behavior observed for the traders that were trading, for example, I don't know, Yandex, and so on and so forth. So each trace relates to a specific order book. So they are, how to say, independent. This is why we can study them independently in this case. And on the other hand, we have the colored Petri net model that describes, according to the real specification of that system that we worked with on the thesis, we got to a colored Petri net model. It's simple because we just focus on a particular subset of order books, because each order book can have it's not that all of them, they have certain rules. Depending on the security, more rules are complex. Maybe it's because of the priority. Maybe one order book is just matters, so who trades first? Maybe the orders that have higher prices, but there can be many more complex rules. So for the scope of presentation, we focused with one particular subset of order books. This is how looks the fixed messages, just to that give you an idea. So this is in Wireshark. So we have a network. This is a program for looking network packages. And the idea was to extract from all these messages the behavior of the agents. And we got to this kind of event log. So we have the case refers to which individual order book. We have the timestamp, so when the event was executed, which activities, and the next 8 columns divided by 4. So ID1, T1, price 1, QT1. These first 4 columns represents one object, one tuple. For example, ID1, in this first row, it's this object with this identifier. T1 is when it was submitted that object, which was the price that he's trading, which is the quantity of stocks. And when you see that there are 8 values in 8 columns, for example, this corresponds to a trade. It means that the order with this ID1 traded with the order with this ID2. So we have events when only one object is involved, or events when there are 2 objects involved. In this particular domain, but in the definition that we did in the thesis formally, we can have event logs where the events involve multiple objects, more than 2. So what we did, we have the model and the log, And this is an example of the file of deviations that we can detect. So what can happen? An example. This trace is the identifier of an order book. So what this row is saying to me, that in this particular order book, in this particular event, at this hour and second, minute, in this activity, this object presented the following deviation. And this description is also automatically generated by the prototype we developed. So what does this mean? That the resource had this state, it was a tuple, but when I executed in the model, one of the attributes changed. Of course, this requires to know a bit of the domain and about the way that we model it to understand what's the difference of this attribute. So this means, if I remember correctly, that the price after the trade changed from 100 to 105, but this shouldn't have supposed it. And similarly, we can capture another kind of deviation. So this is about resource corruption, but also there can be violation of priority. So maybe a token was selected before another. So violating a priority rule. Then we can have also control violation or non-proper termination. Non-proper termination, for example, the last event. So this order book finished and the resource with this ID was not in the final place, but in P6. What does that mean? That at the end of the trading day, one order with this identifier should have been canceled or should have traded, but it didn't happen. So it got there locked in the order book. One nice direction could be of research is how we can exploit this file of deviations. It's not my area, but it would be very interesting how this can be leveraged by data mining techniques. How we can use data mining techniques to give us more knowledge about what this happened. So it would be an interesting combination with conformance checking. Concluding remarks. So these again are the results of the thesis, the models, the techniques that exploit these models, and the experiments that demonstrate the practical value of our approach. The publications. So during my PhD, so I worked from 2018 to 2022. So these are the papers that describe this work. I had the opportunity also the previous year to publish one of these works in the Journal of Modeling Analysis of Information Systems. There is a Russian journal. Presented several conferences. So I had the opportunity in the first year before COVID to participate in Max Pro 2019. And I had the opportunity to participate in the doctoral consortium. So where PhDs of first year, they gathered to discuss about their plan of research. And this was in the first conference on the field of process mining. And the rest of the conference were offline because of the pandemic. But also they were related to the area of analysis of distributed systems and Petrinets. I also had the opportunity to discuss this work in an international workshop of Petrinets 2020. Possible directions of future research. More real-life data, because in the thesis I worked with a particular subset. It would be interested how we can validate another kind of trading systems or other trading systems, tool extension, relaxation of model constraints. Maybe for another kind of systems, the properties of conservative nets or workflow, we can change them somehow and to propose new methods that use more relaxed models in the terms of these constraints and uses of alignments. In this work, I worked with replay. That is the idea to execute. So what's the idea of replay again? Execute the events on the model, one by one. But also we can come to the idea of alignments to try to find a direct mapping between the trace and a possible run execution of the model directly. And for this, there are techniques of finding a synchronous product network and to find the shortest path in the state space. They are a bit more complex, but also would be an interesting research of direction. And with this, I conclude my talk. Thanks a lot for the time and for the invitation. If there are questions, comments.
Thank you very much indeed. I would like to suggest everyone unmute themselves and ask questions in, well, because there are just 4 people attending, we can ask just by voice, no need to raise a hand. But firstly, I would like to say that what do I like in your research, that you with your supervisor or your advisor found a very nice application, not broad protocol verification, very special kind of protocols which should be very efficient, I believe. My only question, my only practical question, I have also a theoretical question, but my only practical question is, well, it is indeed very nice to draw small Petri nets. Small Petri net is a nice specification tool. But even as soon as you get size of Petri nets, especially nested Petri nets, more than 1 page, it is not very easy to read and comprehend.
Of course, yes.
So, because of this, my practical question is, what is regular size of Petri net that used for specification of real event logs? What is size, typical size? 1 page or several pages or a book, maybe even a book. Or an alternative question, maybe it makes sense to design some query language and from this language to generate Petri net. So twofold question. First, about size of Petri nets that are used for a specification of real protocol, real event logs. And next, maybe it makes sense to design specification language from which generate Petri nets.
Okay. As for the first question, of course, in my thesis, or the model or the size of the models are relatively small, so they fit in 1 page. So because we focused on very simple behavior, that still was very useful because it's like induction. So, okay, for this, it worked. So it's theoretically possible and practically because we showed how it works on a real system. So maybe for other kinds of processes of the system, whose expected behavior should be designed on a bigger model, still will work. Now, maybe in other domains, yes, maybe the process models will be bigger. I do know, for example, that in real settings, in real scenarios, or in process business management, the nodes can be in the order of dozens of nodes, and states much more. I do know that for this, that there are strategies, it's not my domain, that is called refinements. So if you need to verify a system and the system is far big, so the number of nodes of this Petri net, it's big, and the number of say, maybe we can get to a smaller model whose analysis will be efficient, will be more efficient, faster, and still it represents the same behavior of the bigger model. So I know that there are techniques for this, for refinement of the model. As for the language of Petri nets, in this case,
problem-oriented language for Petri nets. Problem-oriented language for Petri nets.
Can you elaborate a bit more on this?
Well, once again, Petri net is nice when it is small, but as soon as it becomes large, maybe it would be better not to draw it, but to specify it using some language with some predefined concise templates or something like this.
Like algebra.
Like algebra, right? Yes. But problem-oriented language, not for general purpose, not for general use for all possible Petri nets and their extensions.
Of course, this falls in the discussion of developing formalism. So I know that there is a language that is being used, which is called PQL. So it's on the it's being researched in the community of process mining. It's called process query language. And the idea is to define
very natural name, very natural name.
Yes.
Process query language. Okay.
The idea is to define this behavior in terms of a query. I do not have full knowledge about it. I just read a bit about it. So in terms of this query, to analyze the event log, maybe could be a representation. And actually, maybe in the literature, it's not on my knowledge, there might be similarities to Petri nets in describe it in the way you propose. Okay. Because of the size, of course.
Any other question? Any other comment?
I have a question. Actually, with respect to the slides, the second slide, actually okay. The one. So you were talking about the trading platform. Do I get it right that in your research you can you treat the trading platform as a black box, and actually you basically work with the specification and the messages or logs of network messages?
Yes, we can say like that, because a trading platform, it has a lot of software components. So there is a chapter on the thesis. I also can share it, not only the slides. I describe how actually, in general, a trading system looks like. So from the technical point of view, the trading platform has, it's not only this, of course, it has interfaces. Here we have interfaces for sending and receiving orders, but there are many more interfaces by which the agents can communicate, or any other external individual. For example, before doing sending and receiving orders, there are the agents, they look the current state of the order book. So when someone wants to trade, before sending or receiving something, they look in a panel, okay, the market is like that. So then I will send and receive, they will send my request. For this, there are real-time protocol interfaces, so that they constantly publish the current state of the books, but it's just to publish, and they show to the user. Another interface is for security and clearance entities, for banks. In the order book, we just make like an agreement, but the actual transfer of money is not on the platform. So there is a connection with banks in this side. So you see, from the technical point of view, there are many more components that we do not focus about. We just focus.
But why completely ignore? I mean, in terms of like big platform or heavily used platform, probably there are several layers, like for instance, maybe there is some load balancer, queues, and so on. And actually, the result that you got in the order book might differ from the load on any component and so on. In terms of specification, probably there will not be much problem with that. However, when we are talking about the non-functional requirements of the system, probably there might be some properties defined or criteria defined which might be important to look at.
Yes, I understand. Yes, maybe when one needs to analyze the non-functional requirements of the system, maybe a precise component that can be crucial of interest, we can consider it. In this case, in this particular work, we do not focus on the non-functional requirements like performance, stability. We focus more on the functional requirements and whether they are implemented as the specification does.
Yeah, but in terms of, like, for instance, order, like the sequence might be affected on, basically might be affected by the load on any component, and in terms of like in terms of the whole system, there might be no problem, but actually your analysis would show that there might be some deviation or...
Yes, I understand. So the idea in this work is that, so from the practical point of view, is that for example, the file of deviations, so let me go to the end. So, for example, if we come, okay, we have the model, we got the log, these are the problem of the systems. From the practical point of view, the idea of these deviations could be to help engineers to see where from the outside perspective, because this is also important. So we are doing passive analysis. So we do not know the system inside. So we are looking data that it outputs from the outside. So for example, the messages between the agent and the platform should somehow allow us to infer which precise component. So the activities of a particular component, you see. So this is also a challenge from the point of view of the data. So how to get the correct data to know the activities of a precise component of the system. In the scope of our work, we focus it with the order books because it's what these kind of messages allow us to see. And these deviations can then serve like a small guide for engineers to understand in which components have an error. Of course, if there are many deviations, the file is too big, then we need to make a further work. Maybe we need somehow to refine these deviations or to show more precise to the engineer where could be the problem. Of course, this should be like an additional work in this case.
Okay, thank you very much.
Okay, any other question, any other comment? Well, if there are no more comments or questions, I would like to thank Julio for his presentation. Also, I would like to wish him some luck on his defense next week. And also, by the way, next week, Dmitry Kondratiev also will have oral defense, one of participants of our seminar today, and very frequent, very regular participant and contributor. So I also would like to wish Dmitry Kondratiev success in his oral defense next week. Both of you, good luck. Good luck. And thanks
a lot, Professor, for the invitation.
Спасибо всем. Короткий вопрос. Вы удовлетворены формой в Skype? Все нормально?
Да.
Мы продолжаем в этом семестре работать в Skype в таком случае. До свидания всем. Все.
Thank you.